Okay, hello, this is Max. We're working on fall 2014 final exam, question 5. Alright, so bases loaded. So Ben Bitdiddle notices that any positive integer can be expressed as a sum of powers of 2. So we can do like 11 is equal to 8 plus 2 plus 1, etc. Okay, a basis is a linked list of decreasing integers such as powers of 2 with the property that any positive integer n can be expressed as the sum of elements in the basis, starting with the largest element that is less than or equal to n. Implement sum2, which takes a positive integer n and a linked list of decreasing integers basis. It returns a linked list of elements of the basis that sum to n, starting with the largest element of basis that is less than or equal to n. And so we sort of go in decreasing order. If no such sum exists, raise an arithmetic error. Each number in basis can be used only once, or not at all. So here is our trick. Each number basis can be used once, not at all. This seems a lot like count change to me. So just sort of thinking about this, looking at this right away, I can sort of think about this as count change. So 2's were given 32, 16, 18, 8, 4, 1, 8, 4, 2, 1. Sum to 11 2's. Alright, so here we decided to use 8, we decided to use 2, and we decided to use 1. But it looks like we're skipping 4 here, right? Okay. So this should be super familiar to you from count change. You should sort of see this and be like, oh, okay, well, this looks a lot like count change. Right, so what do we need to do? This is recursion, right? So we need to think of some base cases. So return link.empty. And when do we want to return link.empty? Well, we want to return link.empty if our n is equal to 0, right? So if n is equal to 0, it means we didn't actually need to use our basis at all. We can just sort of give you back an empty link because it required no items from our basis to add up to get to the number that you wanted. Otherwise, what else is possible? So another thing that's possible is we sort of run out of link, right? So we could, if we're given an empty basis, so let's think of this. Well, we know the basis is going to be linked, and so let's say if basis is equal to link.empty, then we'll return an arithmetic error. So otherwise, if basis.first is greater than n, we're going to return sum to n basis.rest. Okay, so they're sort of already implementing some of the recursion that we need to do for us. If the first element of our basis is, so say we have like 32, 16, 8, 4, 2, 1. If our first element is greater, and we're trying to find something that's like sum things up to 15, right? If our first element is 32, we know that 32 is not part of this basis, right? So we could just sort of only consider, or we know that 32 has no part of the sum in 15, so we can just consider everything that's less than 32. And then again, we'll see it again with 16, and so this is sort of like our coins pool. So we have our largest coin, which is the one we're currently considering, and we have two choices. We either use it or we don't use it. And so now we need to consider both of those choices. So, oh, but they don't give us a lot of room for that. Let's see how we might be able to do that. Alright, so I'm looking at this and I'm like, that's a little strange. I don't know. I would normally want to think about whether or not I can consider this element, or not consider this element, right? So I either use this element or I don't use it at all. This first element, right? So maybe there's some properties about bases that will help us. So let's look at some examples. So it looks to me that no matter what, we took the biggest element, we took the largest element that was less than the number that we passed in. Pretty much in every case, it seems to me. So I think maybe we're just safe in having this case deal with elements that we're actually not going to use. So let's think about the case of 11 that we looked at before. So in 11, we had 11. We would take 11 and we'd use that in our basis, right? And now we would have 11 minus 8 is equal to 3. And so now this case would get considered. It would cut out our 4, then we'd take our 2, and then we'd take our 1, and then we would have successfully broken it down. So I think that we're good here. Now we need to actually construct a link that uses this first element. So we're going to actually want to use our first element here. So we'll say basis.first. And now we want to return the link that we get. So saying that, so assuming that this is sort of our n is our total amount, we want to remove basis.first from n, right? So we want to do like 11 minus 8, this operation. So, and we want to get the stream that results from using 2, the stream 2, with our n equal to 3 now. So we sort of got like, we put in our 8, and now we want to get the stream that 3 would return, or the linked list that just using 3 would return. And so let's make a recursive call to sum to n, sum2, and we're going to do n minus basis.first, because we've decided to use that value. And how does our basis change? Well, now we're not allowed to use that number anymore, so we're going to do basis.rest. Okay, and I think that's the solution to that. If you have any questions, post on Piazza or YouTube and we'll get them answered. Thanks.